Hi everyone. In this video, I will start introduction to the larger series of videos about agentic AI. And in this particular video, we will briefly discuss about what the agents are, why they appeared. And I will show you example of one of the agentic SDK by Amazon Cloud Services, which is called AWS Strands, and explain how the concept of the agent is implemented. And then we will try some basic tools out of the box which are provided in that SDK. This is the introductory video to the larger series of videos on agentic AI, where we will discuss all the nuances of how to set up the working environment, how to authenticate with different cloud services, and how to create and run virtual environments for Python. However, in this video, I will just quickly go through the brief discussion of what the agents are and how this can be implemented using AWS Strands Kit. So let's start. So with the introduction of large language models and its wide application starting late 2022 after OpenAI has introduced their ChatGPT model to open public, LLMs had a huge success and a lot of applications in the real world scenarios and business cases. However, we need to understand what the limitations of the LLMs and what the LLMs are. In a nutshell, large language models are just the text generators. Of course, we can use different types of transformer models, not only to generate the text, but also for classification. But here I'm talking about more GPT type or decoding type of transformer models, which are used as large language models. So here we are considering large language models for that purpose to be only a text generator. However, this is already a big step forward because from generating the text, we can now do a lot of interesting things. So for example, we can embed different special tokens in the text, and this will give us a lot of ability to control the flow of decision making based on the text generated by the large language models. So since the main limitation of the large language models, its ability to only generate text, then the question is, how can we enable the power of large language model reasoning and generation with actions? So how can we convert some requests or prompts, for example, for web search, through the LLM to actually implement the web search? And in this case, we use the help of tools. So this can be implemented by using tools called by LLMs, and basically this constitutes the functional structure of the agent. So the agent is a piece of software which is basically a wrapper around large language models and tools. So the large language models within the agent are used to process commands from the user and generate the answers. Sometimes large language model will understand that to generate a certain output, it is required to do some action. So for example, as I mentioned before, do the web search or query a database or do something else, depending on the business requirements. In this case, large language model will call a designated tool. The tool will perform the action, return a result to LLM, and LLM finalizes its generations and passes it over to the agent. So this is a high-level workflow. This is very brief and very functional approach to the agents. There are many definitions of agents. So in order to avoid the discrepancy between various definitions, I am picking up this particular one, which should serve the purpose of this introductory video. So now let's go to the demonstration of the power of the AI agents. In this particular case, we are going to use AWS Strands. So as a first line, I will import Strands library, and I import agent module from the Strands library. Next, from the Strands tool, I will import modules use AWS and file read. This will be our tools. As I mentioned earlier, agent is a wrapper around the large language model, which is a model parameter in Strands definition, and tools. In this particular case, we are using use AWS tool and file read tool. You can specify the model of your choice, but you have to be very careful with the syntax. Recently, the syntax for the model reference has been changed, and you have to put the region code first and then the description of the model. So in this case, we are using US Anthropic Claude 3.5 Sonnet version 2. I will have a separate video to explain different ways how to use different large language models, not only provided through the APIs by various large language model providers like OpenAI, Google, or Anthropic, but also how to use the local large language models which can be deployed by means of Ollama and so on. So we will have a separate detailed video dedicated to the topic only. So now let's try to run the agent, and I have a list of different prompts which I already prepared for this task, and our goal will be twofold. We will be working with the AWS environment, and I would like to create the database in DynamoDB. Then I want to push the data into that database, and then I want to do some manipulations with that database. So basically retrieve what is in the database. The data which will be pushed into the database will be loaded from the JSON files. There are basically 3 JSON files which I will be using. These JSON files are constituting the support ticket dataset, which I introduced in my previous videos. This support ticket dataset can be found in the Hugging Face repository. Here I will be using the nano version, which contains records with 3 fields. Subject, which is basically the high-level description of the support ticket. The description itself, which is a detailed description of support ticket, and a key phrase, which is basically characterized as a class of how this support ticket can be classified. These files can be accessible through my GitHub. I also have a dedicated video about support ticket classification, where I extensively use this support ticket dataset. But also I will share a link to the dedicated repository for the agentic videos. So you to choose where to take these files from. And finally, this is my AWS account, where currently I am running DynamoDB service, and as you can see, I have no tables whatsoever which are presented here. So let's go back to our queries and create the database within the DynamoDB. Before I run this query to create the DynamoDB table, let's just have a look quickly at the process of creating a table manually through the DynamoDB console. So first of all, we have to provide the table name, and then we have to provide a partition key, which is by default provided as a data type of string, and a sort key, which is optional. And this comes as a string data type. So partition key is basically our primary key, which AWS is saying explicitly, so there can be no duplicated values in that key. And again, the default data type for both keys will be string. This is very important, and you will see later in this video how this can be critical. So for now, we just go back, confirm we have no table, and let me run the query. So I have already activated and set up my virtual environment. How to do it and what libraries are needed, we will discuss it in a separate video. But for now, let me just run this Python file, which is called use AWS tool. And before I'm going to run this file, I will uncomment this first query and save the file, which will basically create empty DynamoDB table entitled service tickets with partition key ticket ID and sort key phrase in the US East 1 region. So let's go ahead and run our agent. So the query asks to create the table, and therefore a tool use AWS, which is basically default tool to work with all AWS services, is invoked by the agent. Just say yes for now here. And we have a feedback from the agent. So the agent says, I have created a DynamoDB table with the following specification. So first of all, the name is service tickets. That's exactly what we asked for. Also partition key, it's a ticket ID of string type, of data type string, which is again the default data type as we have seen previously. And the sort key phrase, which is of data type string as well. Our region is US East 1 and the billing mode pay per request. So basically, we are not keeping the instance on, but we are paying for on-demand requests for using our DynamoDB table. And then we have this final message. The table is now being created. It will be ready for the use in a few minutes. So basically, there is some background processes going on. So let's go ahead and see if we can observe this table in the console already. And yes, so we have this table. Now if we go and check the table itself, we will see that the table is basically empty. So there is nothing in the table. So we can see the settings, indices, everything is empty so far. So let's go back to our agent. As I mentioned, our goal is to push the data from the service ticket dataset, which is stored in 3 JSON files, into the DynamoDB. So we have completed our first task of creating a DynamoDB table in AWS. Now, let us use read file tool and read the content of the JSON file entitled disk underscore tickets.json. And in my case, I'm storing all 3 JSON files in the tickets dataset directory. So there are 3 of them: access tickets, disk tickets, and user tickets. So I am given the file name as a part of the prompt, and I'm given also the directory name. And I'm asking to show the content in a tabular format where column names are fields of JSON files, basically the JSON keys. So let's go ahead and run this query again. Now we have a new query. Let's save the file and let's run our agent again. So as you can see now, we are asking to read the file. And okay, let's wait for the end of generation. Okay, so we are asking to read the file, and we can see that agent uses file read tool, which is prepared out of the box. And you can see the content of the JSON file, which is presented in tabular format. So there are 3 keys or 3 fields: subject, description, and key phrase, which we have seen previously in the dataset description. And then in the tabular format, you can see all records. In total, there are 20 records per file, so we will have 60 records altogether. Now, we would like to push this data into the DynamoDB. But to do so, we will have to do some preparations and extensions. So first of all, because I want to push consecutively 3 separate files, and there is no enumeration of the records here, I would like to create an enumeration of each. Also, I want to use that enumeration as a ticket ID, which will be our primary key or partition key. So that should be a unique value. And we will do it in a separate query just in a few minutes. But before that, since I'm gonna consecutively add the records from free file, I will have to maintain the enumeration of the records depending on how many records are there already in the DynamoDB table. So for this purpose, I have prepared next query, which will help us to count basically a number of records which are already existing in the DynamoDB. So I'm going to run now the following query: count number of records in DynamoDB table, service tickets, and here I have to show also the region. Here I also have to mention the region where this table is located. So in this case, this is US East 1, North Virginia. So let's go ahead. Let me clear the screen. So let's go ahead and run the agent again, now asking how many records are there in the table. Now we are again using this use AWS tool, and the return is based on the scan results. The service ticket data currently contains no records, so there is 0 records. The scan operation scans 0 items, so scanned count, and found 0 matching items. So basically, we were looking for the number of records, and the number of records is 0 right now, which is good. So let me quickly summarize what we have done so far. So we have already created the DynamoDB table, which is called service tickets, with ticket ID as a partition key or primary key and key phrase as a sort key. We have already successfully tried reading the data from the designated disk underscore tickets JSON file, which is located in Tickets Dataset directory. Now we were able to retrieve a number of records from the data table, which we have created at the current stage. Since the table is empty, the number of records is 0 as an expected result. So this is the final step for the preparation, and from the next step, from the next query, we are going to do something way more complicated and way more interesting. I'm going to use the following query. I will ask agent to count number of records in DynamoDB table service tickets located in US East 1 and refer to that value as rec underscore number. And here I am expecting that agent will be using the use underscore AWS tool. Then read the file, access tickets JSON, enumerate each record using ticket ID field, starting from record number +1 and format as a string. In this case, I will just modify this prompt a little bit, and I will delete all the part about the string enumeration. I just want this to be enumerated. Why? You will see it just in a few seconds. So then I'm asking show result in a table format where column names are names of record fields. And finally, I want agent to push updated records into DynamoDB table service tickets located in US East 1 region. So let's try and run this agent query and see what happens. Okay, and let's make a pause here. So I have taken a screenshot of the previous generation just to really have a closer look at what's going on here. So we were expecting really the LLM and the agent, which is using that LLM, to perform a number of steps, because our prompt is saying count the number of records. Then we need to read the file access underscore tickets.json, enumerate the records using the special logic there, and show the result table with names of the fields, including the column which enumerates the records, and then finally push the updated record into the DynamoDB table service tickets. However, what you can see on the screen, I've done running the agent twice with this prompt, and we can see that the agent was for some reason only doing the first operation, which is basically counting the number of records in their service ticket. And this is a very important thing to discuss. Obviously, we were expecting the model to make some reasoning and to plan its steps sequentially. However, you can see in this particular case, reasoning doesn't work. So you can see that the first generation here, it's basically counting the number of records, which are 0, obviously, because the table is empty. And the second attempt of generation also results in producing something similar result. But one thing to note here, so first of all, we were not able to get the result we wanted. So model did not reason. And second, since the query was exactly the same, but we see two different generations in two different runs, which shows some instability or basically illustrates the probabilistic nature of the LLM generations, which you should always take care of. So how we can fix this and what we can do about it. So I have tried in the background multiple methods, trying to putting this multi-line string, reformat it, or I was trying to change the content of the query itself. It didn't work. However, when I switched the query from the multi-string query, like this, which we originally used in the previous attempt, I reformatted that entire string, multi-line string, into just a one-line string, just using a single quotes. And in that way, the query worked, and it was possible to make the LLM reason the way we expected to do, and it was possible to produce the results. So since there was really unexpected behavior of the LLM and the agent, I took those experiments in the background, and here is the solution I came up with. So later in the course, I think we will come back to this probabilistic nature of LLMs. But this case of changing the type of the query from multi-line string to, or basically document string into the single line string, changing the behavior of the models. I haven't seen those things before, and I think that can be a nice shortcut and nice trick to make the LLM models work as it's expected. So let me go back to the main course of the video, and I will explain a bit more details there. Also, don't be surprised that now I will have this line commented out, because that's the result of my background experiments. Okay, now let's try to run this query again. And as we discussed earlier, if we use the triple quotes, or basically we just define in the document string and use it as a query, then in the first run, we observed some inconsistency in the LLM run. Now let's try to run this again after we have tried the normal single quotes. So now you can see that Sonnet model is actually doing some reasoning. So it says first I need to look up, count the records in the DynamoDB table, then read and modify the JSON file, and then finally push the data. That's exactly what was expected to do. Now it says let's get started, and it's getting the count from the DynamoDB, for which it's using the use underscore AWS. And now it's reading the file using the file read. Here it is augmenting the data with the counter, understanding that the current number of records in DynamoDB is 0. It will start the records from record underscore num plus 1, basically from number 1, and it is adding the ticket ID as additional field. This is what so far we have expected and what we discussed. So now then, once this data is ready, we will basically use the use underscore AWS tool again in order to push data, basically write data into DynamoDB. Now I'm going to say yes, and let's see what happens. And here is some error. So I notice there is an error with the data type for ticket ID. So let me correct this and try again. So this is something interesting. So the agent says there is a client error, there is exception thrown by the AWS SDK, and it says I noticed the error. So the agent detects the error, and it's explicitly said the data type for ticket ID, there is some error with it, something's wrong with that. So it's asking to do it again. Let's do it again. And still there is an error. Let me continue the reset of the records. So let's try to do it again. And I will continue this process for all 20 records. Would you like me to proceed with the remaining records, or would you like to see a different approach to batch upload these items? So it's basically asking one by one, and for the records one by one, and it's basically quitting. So what is the problem, first of all? Why it's saying there is a data type issue? So the issue here is that we use the ticket ID as our enumerator, and by default, this data type is considered to be integer. However, then we have created our DynamoDB in the first place. We use the default settings where primary key or partition key, which is our ticket ID field, to be string. So this is the main mismatch. So how can we actually change this? Now we can use the query, where we will explicitly instruct agent to do the string formatting for the enumerator, and we will also ask to keep a length of 4. So there should be a string of length 4, leave all the zeros to the left of all meaningful values. So now let's try to run this query and see what happens. Let me clear this long log. Now then run this query, which contains a clear type definition for the counter, basically for the primary key and or partition key. I would like to check that there are no items stored in the DynamoDB database. Looking at the table, we see that our table is in the database. So now we can explore the items, click these service tickets, and we will see that our Tickets Dataset basically contains no items. Now let's go ahead and run this long query, which should count the current number of records contained in service tickets data table. Then say that is a rec underscore number variable, load the data from the access underscore tickets JSON file, enumerate each record in a string format. Furthermore, we request the string to be of length 4 and all non-meaningful digits we should replace with 0. So for example, if we have number of records 23, then the string containing the counter should be 0023. So let's go ahead and run this complicated query and see what happens. Okay, so the agent is reasoning that it's first needs to count the record in DynamoDB. It calls the use AWS tool for that. Then it used the file read tool for reading the files. And now it has detected that the number of records is 0 and it started enumerating the files. It is obviously a string now, 0001, 0002, and 0003, and so on. And now it asks, let me push these records to DynamoDB. I'll do it one by one for each record. Okay, so I will say yes for this, and we'll see what happens. So we expected multiple calls of the use AWS tool to push each record. So now it's continuing for 20 records. I say yes. So now the response from the agent is, I read the JSON file I enumerated from 0001 to 0020, and I pushed the data to DynamoDB table service underscore tickets located in US East 1 region. And each record now has 4 fields: ticket ID, subject, description, and key phrase. And as you can see, there is no error due to the ticket ID data type, because the data type in the DynamoDB for the partition key, which is ticket ID, is a string. And we also requested in the prompt explicitly to use this string data type. Now let's check the content of the DynamoDB. Let's refresh. And we can see that the records were actually pushed only partially. So for some reason, it's only pushed the first record, the second record, and the last record. So now let's try to fix this by modifying the prompt and adding use write batch mode to push all records at once. So now let's see if this modification helps. Just a quick comment. I have erased the originally pushed 3 items. So now the database should be clean again. And this is what we see by the number of records is 0. As we can see from the log, it's going to batch write mode, and we can write up to 25 items in one batch. So this is these 25 items is a very important limitation to keep in mind. And now you can see it's consecutively calling the use AWS tool multiple times. And here in a summary, you can see that all records have been successfully written into DynamoDB service underscore ticket table. So let's have a look if this is true. Let's refresh. And let's order by string by our primary key or partition key. And this time, indeed, you can see that all 20 records are here. Now, as I mentioned, I want to use the consecutive calls of the same query with different file names. So as a next step, let me modify the file name. Basically, let me do one modification here. Just rename the file, copy the name, and update the file name here in a query. So now let me clean the log and let us repeat this process. So what we should see here, the enumeration should basically start from 0021 in this particular case. Okay, so as we expected, current number of records is 20, and enumeration starts at 0021 and goes ahead. So now we ask to do the batch write. Again, we have 20 new records, which is under the 25 records limit, and now it performs the batch. Okay, this is interesting. It generates the error to not being able to process tool. Now it's calling a different tool. Basically, it's calling the same tool, but within the same tool, there are multiple functions to use different service. Okay, so the agent summary is the found 20 records. We read and display the JSON content, and we successfully wrote all records to DynamoDB. So let's confirm it by checking the content of the data table. So previously we had 20 items. Now let's refresh and see what we have. And yes, we start with 0021. This is a new added record. And finally we go to 40. Okay, this is interesting. So let's go ahead and finish. Let's push the final JSON file, put it in a bracket, single brackets, and let's save the code, clean the log, and rerun the agent with this particular query. So as expected, we are first counting the records in the DynamoDB table. Now reading the table from user ticket, and we are enumerating from 41 because we have found 40 records. That's a current count. And now we are pushing the data into the DynamoDB. Okay, so now it says I will continue with the batchers and write in the similar operations remaining records. So their conclusion here pushed all records into DynamoDB using batch write operation. So let's go ahead and confirm. So this we start from 0041. So let's check how our data table looks now. And for some reason, agent didn't push the whole data. So it's stuck at 41, 42, 43, and it's only pushed 4. Let me see. Yeah, this is actually complete. So let's, to check that, let's call the record count query. So let's uncomment our item count query. So now you can see that there are 46 records indeed. So there was something wrong pushing all the records in a batch, which is showing the agent some instability in the agent. So let's try again, roll back, delete these last 6 added items, and let's rerun the query which was pushing our last file user tickets. Save the file and let's run the agent. So we are calling use underscore AWS tool to count the records. Then we read the file. Okay, so the file was read complete. So now we are writing in a batch items. So we'll see whether this time this operation will be successful. Okay, now the agent says that it was able to write all 20 records into the DynamoDB this time. So let's go ahead and check whether this is correct or not. So let's see the counting. Okay, and what it's basically saying, it now split the records into 2 pages. So indeed, the last query was successful. Okay, so finally, once we have pushed our data into DynamoDB, let us do a simple retrieve query. So basically, we are interested in getting all the items where we have a key phrase as grant access. And we would like to return these results in a readable format. So let's unquery. Let me update this. Let me basically say tabular format. So let me uncomment the query and let's run the agent. Okay, so we use underscore tool, and now we can see that it returned, ticket ID, subject, and description. It didn't return the key phrase. So let me update the query here. Use all fields in the original DynamoDB table. DynamoDB table to generate the output table. Tabular format. So let's go ahead and run this again. So finally, this time we have all 4 columns or all 4 fields represented, and we can see that all the records, they indeed have key phrases grant access. So we could successfully retrieve the content of the database regarding a particular conditions. So at this point, let me summarize what we have done and where we were so far. So first of all, we tried some simple queries, like creating the DynamoDB table. Then we tried to read a single JSON file. And then we try to retrieve a number of records in the created DynamoDB table. Then we actually went to more complicated query, and we were not really careful about the data type for the enumerator or for the counter. And we faced the issue with the data type error once we were trying to push the data from a JSON file into the DynamoDB. So we were able to update that with to overcome that error by explicitly saying that the ticket ID should be of string type, and furthermore, we make it even stronger point that we requested the string to be of length 4, and we should fill out all the meaningless values. We should add up zeros to the number which is less than 4. That's basically what we did. And we also requested a tabular format to reflect the updated results, and we pushed our data into DynamoDB. And since there was some instability of pushing the data, we also requested to write in a batch mode and push all the records at once. And there was a limit of 25 items per one batch. So we were not hitting that limit, and we were able to successfully read that. Also, you have seen that throughout the responses of the agent, the response is changing drastically, and we were able even to see some error during the call of the tool invocation. So this gives us to the conclusion that there is a very complicated logic behind these out-of-the-box provided tools, and we have to be very careful and very specific. So as you can see, the details in the query which you provide are very critical for getting the result what you want. Basically, this is a rule of thumb with LLM behavior, but once we enter in the agentic AI field and once we are trying to operate the agents, you can see that this is becoming really crucial in terms of selecting the tools or selecting the specific services within the tool, which is now done, which is how it is done in use_AWS tool itself. And the way you provide the prompt has a very, very critical influence of what the agent is doing at the end of the day. And to conclude this video, I would like to elaborate the code a little bit in some unexpected way. So you have seen that we can provide these different prompts, and throughout this video I was just uncommenting the prompts, but I would like just to make one small extension to this code. So let me clear the log. I want to be able basically to provide a prompt directly as an input parameter for the Python file, or basically give the agent input on fly while I'm invoking the agent file. For this, let us import one more library, which is called argparse. With this library, we will create a parser, which will be basically reading the parameters for the file, input parameters into basically input parameters into the Python file. So this is the code, this is the parser definition, and this is how we get the query out of that. We define basically that this is a required parameter query. So if it's not there, then there will be the error. And once this parameter is provided, they take its value as a query. So now I will take the last query which I used to provide the output of DynamoDB. And I will comment out the query we used the last and save the file. So now that I'm calling the Python file, I will need to provide query parameter. I will paste my query itself. And it should be in one string. So let me go get rid of the unnecessary string breaks. Okay. And let me provide it as a single quote string. So let's go ahead and see if it works. Okay. It looks like agent recognizes the query, and it's basically doing exactly what it should be doing, and the output looks exactly the same what we have seen in the previous run of the same query. So as a quick summary, you can either provide prompts inside the code, or if you want to be more dynamic and provide your query on fly once you run the agent, you can use this query parameter and additional argparse library. So thank you very much. This was an introductory video for the bigger wave of videos for agentic AI, where I will be discussing different aspects of AI agents, how they can use large language models, what SDKs are there. So I will go through Google's agent development kit, through AWS Strands SDK, also through LangGraph and LangChain, which are more common. And I will definitely make a deep dive into how to prepare the environments, how to invoke and start the virtual environments for Python, what libraries to be used, and how to authenticate in the first place if you are using the cloud services like AWS or GCP or Azure. So stay tuned. Thank you very much, and follow me in the new videos of this agentic AI wave. Thank you and have a good day.